For practices self-check is prime, we have the following method, and it attempts to examine a number and return whether that it is a prime number. And we notice that this code is incorrect, mostly because it tells us, and also if we submit this, it does not pass all the tests. So we need to look at why it does that. So we look at these first two lines and they look good. To test this further, we're going to use a test integer. We'll just use the integer 57, and now we can start comparing this. So we notice that a prime number has no factors other than 1 in itself. So this means that it's going to be testing all the factors or all of the integers between 1 in itself. So we're going to run this from 1 to 57, but we're not going to test 1 and 57 because we want those to be factors. Or 1 in n if we were just using a value case. So we're going to start our int at 2, that way it does not test 1, and we're going to run it as long as it is 1 less than our n, and then increment it every single time so that we can test all variables. We have an if statement here, and what this is saying is that if our n, or in this case 57, is divisible by our I, and the remainder of that is equal to 0, our Boolean is false, because this means we have other factors than just 1 in the n, or in this case 57. So using math, I guess in this instance, we would set our n to be 57, and if we divide it by 2, like this, we get a remainder. That means that we're okay so far. This number is prime, but we need to retest this. So we would go again for 3 and 4 and 5 and so on and so forth. But if we change this number to, let's say, be 24, like this, and we used n as 24, we took the modulus of it using 2, we get no remainder. So this is equal to 0. That means our prime is false, and we should return false immediately because this automatically means it's not a prime. So instead of having prime equal to false and returning it later, we're just going to return false right now. And this else statement is actually the issue right here. It's the main issue. It undermines our if statement. What it's saying is that if we are using 24 as an example, we run it in our if statement here, and we use our n modulus 2, and we see that's equal to 0. So this means it's false, right? If we still had prime is equal to false, our prime would now be false. And then if we were to retest this for the value 5, let's say our I is now 5, we've incremented that far, we then take our n, which is 24, take the modulus of it, and we will get a remainder. Since we get a remainder, we're going to go into our else statement because our remainder is not equal to 0. And we're going to be in our else statement, and this actually resets our prime to be true. And since it resets it, it messes our previous result up, because once it's false once, it's completely false, and it breaks our prime value. It cannot be prime if this is false. So this else statement needs to go, and we can just return a true here and return a false here. The reason why, and we can also get rid of this line too. The reason why we can return a true here without any code is because if we break out of this for loop, that means that we never hit this if statement, because this return would automatically break us out of the method. And if we never hit this return statement, that means our number is prime because it's never had a modulus with a remainder that is 0. This means that we can submit this and see that it passes the test, and since it passes the test, this is the code for this particular problem.